Hey, good morning. Welcome to Intro to Statistics. We are going through chapter 7.3 here, and I'm going to skip around a little bit because some of the problems are really small and some of them are not so small. So this is number one, and we have population has a mean of 21. Great. Standard deviation 3. They want to know we have a sample size of 25, okay, and they want to know one decimal place, okay. So we want to know what the average here for X bar is. So what we're going to be doing here is looking for average of X bar, and then we want to know what the standard deviation of X bar is here. You see how the little subscript is there? It's like they have, it's a terrible way of putting it. They're not the greatest with this, but that's okay. It's supposed to be like a sigma with an X bar like that. Okay, and you can tell it kind of comes out like that, but that's not exactly what they have there. So they wanted to know mu of X bar and sigma of X bar. And all they're asking is like, well, what's this is what it's asking, like, this is the average of the averages, okay? And then they want to know the standard deviation of that average. We call it standard error, but you could say standard deviation of the average, that's fine, okay? And we have an n is equal to 25. This is exactly the kind of problem, I would ask a little bit harder, but this is the kind of sample size I would pick. Like, why is that? Because what we have to do is to say, well, the average is still the average. Okay, we're not changing that. Okay, so once we know that mu is equal to 21, we're going to stick with that with 21. Even if we change it then to the averages, that's fine. Oops, I want 21, not 32. 21. Okay, and then our standard deviation here is going to be 3, but divided by. So we want standard deviation of X bar is equal to this original standard deviation divided by the square roots of our sample size. So that's going to be 3 over 5 or 0.60, depending on how they want this. Okay, since it looks like one decimal place, we're just going to type in 0.60. Okay, so 0.60, and we'll check that, and we'll see how we're going. All right, hooray. Right, and then we'll continue on and do one more of these things. A lot of these are actually rather quick. Number 3 is another one that's really small. It says we have a sample size of 7 will be drawn from a normal population with a mean of 60 and a standard deviation of 13. Is it appropriate to use a normal distribution for the probabilities of X bar? So normally I would really want there to be an n greater than or equal to 30. I know the last one it wasn't there, but we're gonna play along as if it was. Okay, I would pick 36 will be better because then there isn't any doubt. Okay, some books use 25, some books will use 30. Okay, some books will use 36. I had one book that used 50. Okay, so there isn't a hard and fast rule, but the consensus is 30 is the thing. So once you've got 30, you're pretty safe with this. Okay. And again, it kind of depends on the underlying distribution as to like how few can get away with. Since we're not looking into that, we're going to go with what this book says and say 30 and not worry about it. Okay. So it's a sample size 7 drawn from a normal population. So normally you'd say, well, wait a minute, 7, that's not bigger than 30. Well, in this case, central limit theorem says it is dependent on the underlying distribution, and the underlying distribution happens to be normal, which means automatically normality gets granted to X bar. Okay, so we don't have to worry about like what was the population. We don't really need to know. Once they told us it's normal, we don't care what the population size or the sample size is. We know that X bar will be normal automatically because it inherits it from the underlying population. Okay, so we're going to know that it's 60, standard deviation of 13. So is it appropriate to use it? Yes, the underlying probability, the underlying distribution is normal, so we should be okay to do that. That's why. So it's yes because the original population is normal. Okay. So I don't like it. I hate when they just ask you yes or no, but yes, because the original population was normal. That's why we can say that. Otherwise, we would need 30 or more. Okay, so I hope that helps a little bit. I hope these go quick for us. Okay, so if you guys have any issues, let me know. All right, thank you.